What's up there, Rose Garden? Hope you're having a good day over there. So we got the pin buzzer synth over here still set up. Yeah, we still got the Larson Memorial scanner set up too, because I can't bring myself to take it apart because it's too cool. We don't need it yet. The pin buzzer only uses that one pin, so we'll let the Larson go for now. And we got these, right? So you know what I'm trying to do here. For those of you that don't know, those are 5-pin female DIN connectors, which accept a MIDI cable, which is really just a 5-pin DIN cable, but they are known to musicians as MIDI cables. And hopefully we'll get a cable to connect from there, connected to this. And from there, we will connect to this, right? We've got a MIDI out in the back there. Thing is, we're gonna have to figure out how the programming all jives, right? There we go, there's our MIDI. Don't even use it anymore, because nowadays we just use the USB, and that's how we get all our information into the DAW, in case this is foreign to you. DAW being the software that we use on the computer to record. It stands for Digital Audio Workstation, right? DAW. And so we're going to go from that out to here, into this. It'll send signals into one of these with its MIDI note messages as we play. And then hopefully this will pick it up somewhere, somehow, and then play the notes that we're playing on the pin buzzer synth. So I'm going to go get to work on that. God knows how many days this is going to take. We're treading in uncharted waters here. So all right, I'll be back. Let you know how it goes.
All right, another fun ride on top of my head with a new GoPro headband build. Glad y'all can make it back. And Totally Ramp, you can make it back again for this one too, CD401.
Yeah, man, totally glad to be back.
All right, let's get right to it. We start out with Le Petit Breadboard, as usual. We add a female MIDI connector. This one's from Adafruit and built to be breadboard friendly. We like that around here. Solder's just so permanent.
And it's really painful.
Really?
Yeah, man.
Yeah, I imagine someone poking you with a hot iron molten metal probably sucks.
Yeah, man. Step off my pins.
Okay, so I just laid down another chip that looks like an IC, but it's not.
You sure? That looks like my grandpa.
Nope. It's a cool little gadget called an Optocoupler. This one is model 6N138. On one side of this component, the signal enters and is turned into light by a tiny LED. On the other side, there's a little optic receiver that catches it and turns it back into a signal on that side. So what we're doing is protecting both sides of the circuitry. If anything goes haywire on the keyboard controller, our synth is safe, and vice versa. So the signal rides in the cable, comes through our connector, goes into the optocoupler, returns back from the optocoupler back to the jack, and this side of the circuit is totally complete and isolated. The rest of what takes place is all on the other side of the optocoupler, in a completely separate circuit.
Why are you messing with all this old MIDI stuff anyway? Isn't there like newer stuff like CV and all kinds of fancy things like that?
Well, I don't know if CV's newer. CV's actually probably older, but a lot of newer high-end keyboards are having CV and gate out and all that stuff. But the thing is, that's a really small subset of keyboards out there, of keyboard controllers, and I would really like the synth we're building to be accessible to everyone. Maybe we'll add CV later, but I want to have at least MIDI, just so that anybody can hook up any keyboard they find and just go, you know?
Sure. Smarty pants.
So we use a 220 ohm resistor to wire the jack to the optocoupler, and we add a protection diode across pins 2 and 3 of the optocoupler as well. With that side done, we can focus on the synth side of the optocoupler.
Do you know how many times you just said optocoupler?
And you know how many times you said no when we ran power into you the other day?
I'm not sure that's fair. That's my job, man.
We're finishing wiring up the power to the optocoupler right now. We got a couple resistors leading away from the optocoupler as well, but the important part here is we're running power in, we're getting power from those two little wires that are dangling off the side there. Will eventually connect up with the bigger board. We're going to run one wire from pin 5, I believe it is, on the optocoupler over to, I'm sorry, pin 6 on the optocoupler over to the Cestino chip right there on pin 16. And that about does it. This thing is wired up. So now all we gotta do is wire it up to the keyboard, hopefully. Just a few tips before we head over to testing our rig and running through the code. First of all, I intentionally left the code at the end. So if that part is a slog for you, go ahead and bail when it starts, because it goes and goes until the end. Second, I used the schematic from the notesandvolts.com site. When I was figuring this out, I was led to believe the simpler circuits than this one that you can find out there are probably not something that you want to hook expensive hardware up to. Built to this schematic, both sides are protected from each other as we spoke about, and it adheres to what the MIDI specification recommends. If you're going to dig into this project at all, it's highly recommended you poke around at the MIDI specification. I'll leave links to all this stuff on the site, http://electricrose.live.
So here we go. We got Cestino MIDI module, newly completed MIDI module, MIDI cable, zoop, to MIDI controller. Everything's on and working. Our new sketch is in there, and there it is. It works. Pretty sweet, right? It's the weirdest thing to play out of a controller and have it coming out of a little bunch of electronics. It's really odd. Really funny. It's really funny to me. And it's pretty fast too. It's it can handle whatever I throw at it. Except up here it gets weird. You know, it's just programmed with that tone function and frequencies. But we get up to the frequencies up here. Whatever's going on with that frequency makes it wonk. So then this key goes down. There's some wackiness. I could do that for far too many days in a row, surely. But yeah, weirdness. Who knows? Maybe we can figure out why. Maybe somebody out there who sees this can tell us why. Because that's weird. I'm going to look some stuff up and see if I can find out. It's not that important. Because this is not our ultimate sound that we're shooting for with the Electric Rose, obviously. Let's go take a look at the code for those of you that are interested.
Okay, code monkeys. Let's take a quick whirlwind tour through this so we don't burn too much of your time today. I abandoned our current pin buzzer code because there wasn't much to it and it was just kind of fragmented and thrown together. So I went looking for something, because it's all based off of the tone function, everything we've been doing. So I figured surely there's something out there that's a little more advanced than that, and there was. Within the library that we use for MIDI, for the MIDI in, there is a sample called Simple Synth, and that's where we derived all of our code from, most of our code. We only needed a few lines to make things different. So real quick, let's open up your manage libraries if you're following along, and all we're going to do is add that MIDI library. I just want to make sure that you know the correct one. So let's look at my installed libraries. Communication, right? Because we're communicating through MIDI, and then MIDI. And I think it's down here just a bit. I missed it. Where'd it go? There we go. This MIDI library by Francois Best, version 5.0.2. That's the one you're looking for, and that comes with everything that we need. And there's our Simple Synth up on GitHub. So you can pull this up. It'll work on any one of these chips. It will definitely work with our Cestino because we've done it. So make sure that's installed. Once you have that installed, go to File and then Sketchbook or Examples and MIDI library down here. You have all these, and there's Simple Synth right there. So I just opened that up, made my own version, stored it away. Call it Joe's Simple Synth so I remember which one it is. As far as this code goes, there are only a few alterations we need to make. First of all, the main reason that I wanted to go get code was because I knew someone had done this already. There's pitches.h here, where there's just a define here where they have every frequency for every note. There's B0, C1, C#1, and it goes way up beyond what the keyboard can do. So I didn't have to go fish out this data or make it happen. I did check it because of those weird notes that we've seen to make sure that it was right, and it is correct. So there's something weird going on within the Cestino that's causing that problem, or somewhere in the programming. So that's pitches.h. If you don't know what's up with this, it's just a header file, a C header file. It just has some of the information that the program needs, is the simplest way to put it. So there's a bunch of defines there that all have the frequencies for all the different notes, and at the very end they just build an array, which is just like a list of things, and it's just a list of all those notes in the whole entire sequence here. So for easy access, essentially. So there's these two other files here other than our main program. There's notelist cpp and notelist.h. These files hold the blueprint for a couple data structures, which will quickly store and give us access to any info we need about the keys currently being played. The code in these files uses some advanced C++ techniques, but we don't need to have a full grasp of the code in these two files to make good use of them. To grok this chunk of code, we need an intermediate grasp of C++, including pointers and templates. Up here, there's this struct called MIDI note, and it's just a little container for holding the information about a note. This is the main part of it right here. 2 bytes, one called pitch and one called velocity. It's obvious what we need that for. So every one of these is a little tiny package that stores all the information about one one happening with MIDI coming in. And then this is the MIDI note list. What this is a linked list. It's just a list of items, right? And it's going to be a list of these MIDI notes that are being hit. And a linked list is just a list where every item on the list knows where to find the next item and the previous item on the list. And I know that's a little weird, but if you're interested in more of this business, go look up linked list and start learning some heavy duty C++, and this will a study of this is well worth it. I'll put it that way. But if you don't want to go through all that, you can just use this linked list, and that's what we're going to do here. We're not going to invest too much more time in that. And that's it. The CPP file, the way they did these functions were all in line, so everything, the entire code for this whole thing is all in the header file, which I know could be all Spanish to you guys, but don't sweat this too much. That's if you want to understand more, those are the two things to go look more into: linked list and C++. Over here in the main file, nothing is nearly as hectic as all that. We include the main library, the header for the library that we just added to our system, right? The MIDI library. And then we're including the note list, which is what we first talked about. And then we're including the pitches, right? Those two files that we just went through. So right here, the one thing I had to change, this is the original line, MIDI create default instance. This just sets everything up and gets it ready for usage, the main object that we're getting from this library right here. Well, the thing is, on the Cestino, we have that first port, which is dedicated to talking with the computer, and we might as well just leave that alone. And we have a second port available on the Cestino, so I figured we would just use that and completely ignore that other one. I have to play all the other games that people play using the same port for multiple things. So we just took this line and commented it out, MIDI create default instance, and we just did a MIDI create instance instead, where we could give it our own arguments, and we put in everything here is what the default has anyway, but the one change we have is here, where we change serial, which you would normally use for the first serial port. They name the second serial port in the Arduino system serial 1, and then the next serial port is serial 2, and so on. So we just had to, that's really the only reason we have this, is because we had to change that. We just wanted to send out this information through serial 1. This is nothing to worry about. This just has to do with a specific piece of hardware, not having this function implemented, not want to cause problems with the code. Nothing for you to worry about unless you're dealing with one of those. If you do, you probably understand this. Then these are important right here, and these are the only other changes that I had to make this work. This gate pin, I set this to 22. Because we have, well, let me explain this first. The first thing is the audio out pin. This is, and we've been using pin 21 for this anyway, so I just set it up to continue to use that. And then this little piece of software also has the ability to send out a gate signal, which is something that is used often in a lot of synthesis, a lot of the like Eurorack stuff, and far beyond that. So what it is essentially is when you hit a note, you want to be able to send a signal somewhere that says, hey, a note was hit, and you send that to something like an envelope or something that changes the sound somehow, so it knows to start doing whatever it does. So this sends out a signal when you hit a note. It also sends a signal out of this other pin that says, hey, signal's coming, right? And then when you let that go, it's going to stop that. So it's just basically a signal that says, hey, a note is being pressed or not, right? So it has the ability to do that. So you can use external hardware to deal with all this, which is really interesting. There might be a fun project for us in the future there, certainly. This next thing, S-Max num notes. That's basically when you look at this, it's the number of keys that it will track at the same time, and it's just not that big of a worry for what we're doing here. This MIDI note list, this is where we're declaring, we're creating one of those objects that we were talking about in note list, the linked list. This is a linked list. This is that linked list, and we're calling it MIDI notes. Then we have a few functions here, but we're going to jump down a little bit for a few first. We're going to go down here to setup and loop. I don't know if you're Arduino people or not. I would not call myself that. I know enough to get by. But if you are new, these two functions you'll find in every Arduino sketch. They are your main window into working with the programming. You create two functions, which are basically just an inlet for you to write your code. The setup function, which is up top. Everything from the left bracket to the right bracket after it says setup parentheses. That is all run one time, the first time that the sketch is run. Sketch is just a little program. It might as well be called a program, but they call it a sketch, so you know it's Arduino. And the other function is the loop function. Once the setup function has been called, and it does what it's going to do for the first time setup, the loop function will continue to be called over and over again by the system. So whatever it is that you want to be done through the life of the program must be done in that loop. In our case, the only thing we do is ask our MIDI library to read what's going on the MIDI port and distribute the messages accordingly. Now, what do I mean by that? Well, let's look over here in setup. The first thing we do in these first two lines is we're just setting the pins, the two pins, what we designated the gate pin and what we designated the audio out pin, and we're setting them both to be output pins, right? Obvious stuff. Then the next two lines is where it gets funky with the MIDI. We're using the MIDI object that we created, and we're calling the set handle note on function within it. And that function takes an argument, and what that argument is the function that we want to handle when notes are pressed on. Simple enough, right? And also we want to know what to call when we let go of a note as well, right? If we know when a note starts and we start playing it, we need to know when to stop it as well too, right? So that's what this business is all about. These are callbacks is what that's called. And we're basically just setting up a little place that's ready for the system. And this, when these things happen, when a note is pressed, the system will grab the message and go, okay, pass you the message, and is where your function picks up and goes, okay. After we set those two things up and those functions are ready to go, handle note on and handle note off, then we call MIDI begin and this whole process begins, right? It just starts it all up. And then once it's started, then over here in the loop, we hit MIDI read and it will do everything it needs to do. Now when that MIDI read hits, we're going to catch one of these two things happening, right? Because that's basically what we've set handlers for, right? There's a lot of other handlers in the library that you could use to catch other things. So the two functions that we're calling are handle note on and handle note off. Let's take a quick look at those. Handle note on takes three things. A byte has the in channel, the in note is a byte as well, and a byte is in velocity. So it's just basically the MIDI channel that data is coming in on, the note that is being represented by this little packet, and the velocity that that note was hit at. That's it. All good stuff to know for this, right? So without worrying too much about some of this, the first note right here it's asking the linked list of notes that we created, right? The big list of notes is going to keep track of what's being held at any one time, what notes are being held at any one time. And it's saying, is this the first note, right? It's asking that list if it's empty. MIDI notes dot empty. There should be a question mark there. There can't be, but that's okay. In your head, you can hear it empty. And is it empty? Well, if it is empty, then that Boolean called first note will be true, right? So first note will be true. It is the first note that's being hit. If empty is false, then first note will be false, right? It's not empty. There's already notes being held. So first note will be false in that case, because this is not the first note being held. In this next line, we're adding the note that's being hit to the linked list. You see in parentheses there, it says MIDI note, parentheses in note in velocity. Well, what's happening here is that we're calling one of those functions that was created inside of this note list CPP that we looked at, where the linked list blueprint was. And it's creating one of those MIDI note objects by us giving it what note was being hit and its velocity. And then this right here returns one of those note objects. And then we're going to use that note object and we're going to pass it into the linked list using the add function of the linked list. So then that note will be part of the linked list. And then we call handle notes changed, and we're passing in, is it the first note or not? So that's cool. In the end, it winds up calling handle notes changed. If you look down here, you'll see our handle note off function. Okay, this is what we set up here to, down here, to be the handler for when a note is released, right? A note is off, we set the handler right here, and we set to be handle note off. So you go up to handle note off. This is what happens when someone lets go of a note. And we also, once again, get the channel, the note, and the velocity. And all we do is we go to that linked list again, that same thing, and we're calling its remove function. And we're going to pass in the note, apparently, is what it takes to find it and remove it. Right? So that list of notes is currently being held. Once you've released it, now it's going to go to the list of notes that we're keeping, right? So we know what's going on out there on the keyboard. If they let go, well, it's time for us to let go. So then we remove that from the linked list of notes that are currently being held. And then once again, we hit handle notes changed, which is really one of the main points of what I've been talking about here. Because we got these two functions that were both called for two different things, right? Handle note on, the handle note on and the handle note off. But in the end, we wind up calling the same function from both. So it's kind of merging the logic into one thing, right? Where one of them is passing in the first note, whether it's true or not, that it's the first note that we're dealing with. And when it's off, we're not passing in anything at all, right? Interesting. So we come up here and we look at handle notes changed, right? And it has accept a Boolean called is first note, which we already knew down there. We were passing it in. If MIDI notes.empty, well, MIDI notes is that linked list again, right? So it's saying empty. Remember we talked about that function a second ago. It's calling the empty function of that linked list. And it's saying, do we have anything in there? Is MIDI notes empty? If it's empty, then what we're going to do is we're going to call handle gate changed false, right? So this has to do with that gate thing I was talking about before. Basically, if there's no notes, we're going to shut that gate down and let it know there's nothing coming out. There's no more keys, right? And then we call the no tone function in the next line on that audio pin that we're using for all of our audio out. And obviously we've released the last key, right? There are no notes, so there should be no sound. So no tone it, shut that tone down, right? That's the opposing function to the tone function, right? This else down here, this is the else to this if up here, right? So if MIDI notes is empty, right? So this is basically if MIDI notes is not empty down here, right? So we come from this else and we look at, we have, they said byte to the current note equals 0, all right? So we're gonna, what they're basically saying, this is just an initialization. They're creating a variable called current note. We're setting it to 0. That's all that's happening here. If MIDI notes get last, current note, okay. So the way this function works is a little weird. We're passing current note in, and if there is a current note, that function, the get last function, is going to fill that actual variable with what that current note is. So it's being passed in as an argument, but it's going to use that address to stuff a value in there. So when that function comes back, if it comes back with something true, right, with the actual return value, because you see how the if is onside the get last function, right? If there's some kind, if it returns true in some form, then that will mean that current note has a note in it that we should play, right? So the next thing it's called is the tone function. We do exactly that. We call it on our standard audio pin that we're using, and then we go out to our pitches finally. We use the pitches array, and we send it the current note as the index. So we'll know that'll pass back the frequency to play, and that's what will be played with the tone function, and it'll do that until it's stopped by that no tone function later. So after we play that tone function, we're saying, is this the if is first note? So we're actually asking, is this the first note again? Did we go from no keys being pressed to one key being pressed? And if that's the case, handle gate change true, we're going to start sending out that gate signal I told you about, right? So we're hitting a note, that gate's going to go ahead and turn on. So whatever's out there, if there needs to be something that makes it go, it will start that, right? And the else is if it's not the first note. And if it's not the first note, then they're doing a thing, they're sending a pulse gate out of the gate, which is just, it's going to dip the signal real fast just to let it know that there's a new note that happened. So if an envelope or something needs to be re-triggered, it knows it should start over again because there's a new note. It says you could remove it for the legato effect. And what that basically does is if you have some kind of envelope or something changing something, is doing that, when you trigger it, it'll start again, right? So if you don't do that, it'll just continue to hold that out, but it will change the pitch of the note, right? I know that's a handful and a mouthful. And the only other things in this piece of code that we haven't looked at are up here where the handle gate changed is. And the only thing that we're doing is when we set with that boolean we passed in the handle gate changed, whether we want to set the gate active or inactive, right? Depending on what was passed in, it just sets it high or low. And when we sent out the pulse gate, you'll see all it's doing is changing, it's shutting the gate off, waiting for 1 millisecond, and then turning the gate back on. And that's about it. I think we've covered this whole entire piece of code here, so you have at least a good overview if you want to go play with that. There's lots you can do from that position. Our point was just to get a test of our MIDI input circuit, and we got it, and it worked. And so there you are.
Well, kids, that's all I got for you today. Hopefully, if you were trying to get a MIDI circuit going, you got one going. If you did, mission accomplished. See you guys next time. Have a great week.